Good afternoon, everyone, and welcome to our webinar, Winter Resilience Smarter Energy Management for High Usage Businesses. Thank you for joining us today. My name is Nadine McLennan, and I'm Head of Brand at BCR Associates. As we head into the colder months, businesses with high energy usage face unique challenges: volatile markets, rising costs, and increased demand. Today, we will share practical strategies to help you manage risk, optimize performance, and build resilience in this unpredictable energy landscape. Before we begin, just a few quick housekeeping points. This webinar is being recorded, and we'll share the recording with you after the session. We'll have a Q&A at the end, but please feel free to send through questions through the chat section at any time during the presentation, and we'll collect them and address them as many as possible during the Q&A section at the end. About BCR Associates, at BCR, we are more than just an energy consultancy. We are a strategic partner for smarter energy management. We are proud to be certified B Corp and EcoVadis rated company, committed to sustainability and ethical business practices. Our mission is to help businesses reduce cost, manage risk, and achieve net zero goals. So what do we do? At BCR Associates, we provide a comprehensive suite of services designed to support business energy strategies, which include energy procurement, so we can secure competitive contracts and mitigate market volatility; energy management, leveraging smart data insights to identify inefficiencies and optimize usage; compliance and carbon reduction, supporting ESOS, SECA, and net zero obligations; and risk management, building resilience against price fluctuations and supply changes. Our aim is to deliver visibility, control, and confidence in energy decisions. So first of all, I'd like to introduce our speakers. Richard Dormer, our Managing Director and founder of BCR Associates. Richard brings extensive experience in energy strategy, risk management, and helping businesses navigate complex market conditions. Gemma Dormer, our Compliance and Sustainability Specialist at BCR Associates. Gemma focuses on regulatory compliance and carbon reduction strategies, supporting organizations on their journey to net zero. And together, they will share insights, practical actions to help businesses prepare for winter and beyond. So I'm going to introduce you to Richard. Over to you, Richard.
Thank you very much, Nadine. Why are we talking about the winter? Really, because the winter is a period when our costs and risks tend to go through the roof from a point of view of business. BCR really focus on the three core pillars of energy management, sustainability, and reducing costs. So it's costs, consumption, and carbon. If you want to reduce the cost, everybody wants to reduce the costs or manage costs at least. We need to address the consumption peak times and consumption through sort of through the base load of any sort of site, and this as a consequence will reduce carbon. If you want to reduce carbon, you do exactly the same. You look at consumption and look at how you use energy and where you procure energy, and that's going to be something I will talk about in the future. Well, not in the future, but what the future means for the carbon world and the consumption world. This is a diagram of the demand of the UK, the whole UK, energy demand of the whole UK across the 24-hour, across 2024. Excuse me 1 second. Apologies, I seem to have grayed something out somehow. I have no idea how. Sorry, we'll go back to that. This shows the energy demand across the UK in 2024, and as you can see in the areas with the tall blocks, it's really the winter months, the January to February, November, December, which is where our majority of our costs are and the majority of our opportunities to save are. Whereas the summer months in the middle, there's relatively less opportunity there, even though that we may be having solar and renewables sort of kicking in, but really it's the winter we want to be looking at. Let's start with heat. And the big question I always get asked is, how can we control our heating costs? When should we put the heating on? Realistically, you shouldn't be putting the heating on in the traditional sense, because you should have automatic. It's best to have automatic controls. The BMS needs to be set up with the right set points and the right timings. But often we find that the BMS systems in sites where they have them are not set up properly, or where there aren't BMS, then it's very much a very reactive thing. This is a graph. I'm going to be quite graph heavy today. This is a graph of the demand created by a need for heat, because this is the temperature curves of 2024. As you can see, the thin orange ones are the maximum daily temperatures. The blue ones down here are the minimum daily temperatures, and then the areas in between are the days above average and days below average. So as you can see, from here we can sort of say, when do we need to heat? The dotted blue line is 0, and obviously we need to be heating our offices when the outside temperature is freezing. But when does it start and when does it end, and how should you make that decision? Let's look at those parts of the consumption where we looked at consumption before, where the main problems are: November, December, January, February. And if we look at, if you can see my cursor there, right on where the curve intersects this sort of first box here, that's about 5 degrees. And as you can see, some days you're up to 10 degrees on the orange areas, and some days we're down to below freezing in that period. So when in that period do you think you should be starting to heat your building? Realistically, thinking about at this level, where the outside temperature is 6 degrees, we all know we should be heating our building, because it'll be pretty chilly on the inside. However, what you must realize is that, or appreciate, is a lot of buildings have a lot of assets inside. So we have a lot of printers, we've got computers, we've got even just people. People are equivalent to 40 watts of generation of heat per day. So a building will sustain a level of heat just through the operations. And what we tend to look at is somewhere between an outside temperature of 12 to 14, 15 degrees is probably the most appropriate time to start heating. So as you can see, the boxes here are intersecting where the temperatures are around the sort of 14, 15 degree mark. At this point, you're looking at minimal cost to actually bring the offices or your sites up to sort of 21 degrees, where a lot of people sort of have their offices running. The grey areas here, the grey wibbly areas on the graph, that's kind of where you start having the choice of which should it be on, should it be off, because really you're ending, if you're not careful with uncontrolled systems, you can end up heating the offices or heating the buildings for the entire 12 months. So here at the moment, we've extended out from January to April, and then suddenly the grey areas become May to June. At what point does it feel comfortable for everybody to have the heating off? And similarly at the other end of the scale, on September through to October, November, December, what you'll find is you can't please all the people all the time, and you'll need to sort of actually find out which people are susceptible, which areas are susceptible to the cold and the heat. But as you can see, in these areas, it's really important to be able to sort of manage your energy. And if I just go back to that one again, these are the areas of the majority of your costs and the majority of your consumption. So these are the areas you should be focusing on. A lot of people say, what's good look like? Or how good should good be? This looks quite anonymous graph, but actually what this is in the golden sphere, the golden ellipse there, that's actually the day-to-day consumption during the Christmas holiday period. So this is the sort of the week between Christmas and New Year. This is actually a school. And the green bars are the heating and the blue bars electricity. Now, this is a school we've been working with for a while, who have our energy management platform, and therefore we have the data. And as you can see, the blue electricity is right below, is bang on their sort of baseline. So here we're looking at the things like the servers, the security lights, the alarms, all the things that aren't going to get turned off. And this is something they've been working on for quite a while, to actually sort of mirror this profile, which frankly, when people go home for Christmas, they tend to turn stuff off, to the rest of the year. And so you see these red circles here. This is the previous weekend, and then the weekend before that. Yes, the gas consumption is slightly higher, but they're very good at keeping their electricity consumptions down when nobody's on site. The other end of the scale is this is a firm of lawyers and accountants, where they've done a similar sort of thing as far as this is the Christmas period. As you can see, they kind of worked, this is their electricity in the green and the heating in the blue. As you can see, they worked right the way up to the wire. This is a kind of Monday after the weekend, and then it's through the Christmas period. So they actually managed to turn down their energy, and they turned everything off, which kind of matched their previous weekends. What they forgot to do was do anything with the heating. So these were offices that were empty for over a week, which then resulted in a £1,245 bill for the period when there was absolutely nobody in the offices. So it's really a good return on investment, actually having a look at what data you have, installing data, and getting this kind of level of saving. So if you haven't got any data, or you're just trying to get some data and some systems in, what can you do outside of that? What are the really obvious to do things? First thing is go and stand in the boiler room. The boiler room in most sites is a wonderful place to be on a cold winter's day, because it's lovely and roasty and toasty. The reason being is because you have these sorts of things, which is a manifold on a heating system. It doesn't really matter what it is, but that, when you put a thermal camera on it, is absolutely glowing. You don't want to touch that. That's pretty hot. And what it should look like is that, because the heat that's coming out of that manifold there is heating a boiler room, which doesn't need heating, not heating your offices. So it's literally radiating money and waste. In the same boiler room, the installers did actually put some insulation in there, as you can see the silver sort of foam bits around the pipes, but didn't actually go that one extra step of the hassle and the expense of lagging the bronze valves. That should look like this. Again, it's hemorrhaging your money into the boiler room when it should be that heat should be traveling around your building, heating your staff. Now there's a number of areas we look at. So this is a kind of wet system, which was inefficient. After they did some very minor remedial works, brought their efficiency up. And then we looked at sort of how we could do the other area, which is the air handling and sort of air conditioning in the offices. Now we're very interested in what technology comes onto the market, what's being proven, what's useful. And I'm just going to hand over to Gemma to show you a little bit about sort of what we've done with the data we put on site, because without having data, you can't really measure any efficiency. So my colleague Gemma is just going to take you through what the data for HVAC looks like, and sort of how you can actually identify efficiency, and then show you a couple of projects that she's been involved with. Over to you, Gemma.
Thanks, Richard. So this is just to have a look at how small changes within your building can have a big impact on your heating efficiency. So this one's HVAC optimization. So this is some data, not from one of our projects, but some that they've kindly shared with us. So this is looking at data from the University of Greenwich. They installed a small piece of technology onto their HVAC system to improve the efficiency. So the blue line that you can see is before the technology was installed, and the green line is after, and that's then been normalized for the outside temperature. So as you can see, this delivered a 17% reduction in heating consumption just by controlling the HVAC system in a more intelligent manner. So it's a small unit, which you can see here on the wall. And so what the unit actually does is fairly straightforward. It monitors continuously and adjusts the compressor within the HVAC or a heat pump or refrigeration, so that the cut out and cut in points run at more efficient pressures. So in some simple terms, each time the compressor runs, it delivers the cooling more effectively, so it doesn't need to run as long to achieve the same temperature. So by closely managing the compressor operation, because fundamentally compressors are just pumps, it achieves a 15 to 25% reduction in the energy consumption. So this particular system, the Eco3, has verified demonstrable savings. It's been installed in like 35,000 sites, and has been tested using the panoramic power system that Rich mentioned to validate the performance. So because the controller sits alongside the existing BMS thermostat, it's not overriding the system, it's just stepping in to improve efficiency. So it's standalone and doesn't interfere with any warranties and functions just like a controller to make things work smarter. So another interesting technology that looks not at the HVAC, but at your boilers. So one company in particular has taken a chemistry-based approach to improve the performance of the traditional wet heating system. So this focuses on how the water behaves as a heat transfer medium. So they use an additive that changes the heat transfer characteristics, so flow behavior, bubble formation, overall quality. So this means that the warms up faster, so the radiators reach the temperature sooner and the boiler fires for less time. It then allows the radiators to give off the heat more easily, improves the circulation efficiency, which means that there's less overshoot and fewer unnecessary firing cycles for your boiler. So it's technically complex, but the outcome's simple. The water absorbs and releases the heat more efficiently. So once the target temperature is achieved, this reduces the wasted energy and results in an average of 15% energy saving just by adding this into your water system. So the key takeaways is you can't please everyone. Someone's going to be cold, someone's going to be warm. It's a fact of life. But secondly, people jump to buy a new boiler, upgrade the heating system, but the real foundation is the data. Understanding how your building is performing. Data and maths will reveal the inefficiencies fairly quickly. So if your consumption profile looks like the one on the top, you've got it all over the place, unstable, spiking, or consistently high, you're probably wasting money and it's time to act. So small practical checks will get it to look more like the lower graph. So are warehouse roller doors left open too long? How long are the doors staying open when something comes in to be loaded? Are there curtains? Are you insulating your boiler like Richard showed? Are your boilers old? Older boilers can use 10 to 15% more gas, and having the data on hand can help you quantify this and validate the savings. So I mean, even set points matter too. So reducing a set point by even 1 degree can cut costs. So and don't forget heat recovery. So don't heat things twice. Capture the waste that you've already got and reheat within the system. Okay, so this is another example of where data is really useful. So this is an example from a school site we visited. And the building was empty, and yet everywhere was plastered with these. But having that data on allowed us to identify what was happening. So this is where the director noticed that all the lights were on during the night. It was not happy. So this is, as I said, noticed it's on 24/7. They then start having manual interventions. So they're going in and turning them off every night, not going to be done consistently. So then they got the electrician in to come put in new lights. But then they noticed that this was not actually having an effect because it hadn't been done properly. The director unhappy again. So then they got them back in, got this set up to be actually turning things off properly. And you can see that it's got some regularity. However, they did go cheap. So this then started failing and not having a good time again at the end there. But so yeah, advice here is just don't buy things cheap online. Have the data to back things up and always assume that it's not been done correctly, so that you can then see if it's worth it, so you don't end up paying twice. Back to you, Richard.
Thanks very much, Gemma. Yes, I do remember that client. It's sort of one of the learnings was it's easier to do things right first time than actually have to retrofit. I think there's even examples in there where the good electricians, but they're not lighting engineers, had one, not got the data to hand, and two, they screwed these fittings in the way they wanted to, which had kind of broken through some of the seals, and these lights were full of water after sort of several weeks. But anyway, they kind of learned to sort of do things more appropriately in the future. So somebody's asked online saying, so what is this? How do we get energy data, and how's that look like? And this is an example of some of the sensors we use. These are little orange boxes. These are clip-on CTs. The big advantage of these is there's no fixed wiring. These are transmitting out to a radio hub to get data out, and these are very easy to install, very easy to clip in by sort of a competent electrician who doesn't have to do anything to connect live wires, and can be moved around. So once you've sort of in this distribution board here, which is looking at some lighting loads, once that's been done and you're satisfied with what's going on there, you can then move these to another site. So it's a very, very efficient, cost-effective way of doing things, and you can pretty much measure any load in the building. This particular system delivers a lovely dashboard and there's a lot of analysis down here. So any point in the day, your on-site facilities or your energy manager or your facilities manager can see exactly what's going on, see exactly where the problems are. So this is a common system that's used very much for the on-site operations, as opposed to sort of looking at the sort of the fiscal level. So what we're talking about is resilience, and being able to make changes in the winter on a day-to-day basis to get the best result is important. There's no point waiting for the sort of the end of the month half-hourly data, or waiting for your billing to come in, because by the time that you see the increase in consumption and increase in costs, there's not a lot you can do about it. Gemma showed a building with all the lights on, and it was quite interesting that they had a lot of energy management and energy efficiency signs and posters everywhere, but nobody was actually doing anything. So the big learning there is you can engage with people, but people do tend to forget, and when they're not at and they don't treat their workplace like they do at home. Most people turn off things at home, but don't turn off in the workplace. Now here's a case study from an LED consultancy. If you look here, this is Pilgrim, so it's a big cheese factory, and this is in their chiller areas, and this is a comparison between old LEDs. So this isn't where they've got old style lighting in place that's sort of an obvious fix. This is somewhere where they're saying we've already done LEDs, so we don't need to look at that. Well, that's fine, but we'll have a look anyway just to see what's going on, because frankly, technology moves. And the technology of LEDs is just like computers. It's moved over the last 5 years, 6 years, 7 years dramatically. So this line here at the top, this is their consistent LED usage over a period. It was quite obvious when you walked into the warehouse, the LEDs were always on, and also on bright sunny days, right below skylights, and with the doors open. In the middle of summer, and you think, well, actually, these lights shouldn't be on. So the modern lights will account for this. So what they've done in the past was they bought a bunch of LEDs. Their on-site guys had fitted them, and this was the result, which is not bad because it's just below 4 kilowatts. However, we then modelled that against a new installation, and they took it on board, installed modern lights, and effectively reduced their consumption down to here, where you're showing the daylight reactions of the lighting, and also it's going off overnight. So what's happening is, as the light levels come up, the need for lighting goes down. These are much more efficient luminaires. As you can see, they're operating about 1 kilowatt across this level of units, as opposed to the 3.5 kilowatts. And this resulted in a quite reasonable 82% cost saving, and a 65% saving in their which was predicted against their consumption. So this is a highly effective way. If you've got existing LEDs, and they're saying, well, we've got LEDs, this is the where we should be in this day and age. I mean, if you bought your computers 8-9 years ago, nobody would be sitting there saying, well, we've got computers. You will have updated those already. And this is actually the same for lighting. So we've talked about heating, and we've talked about lighting, which are probably the two biggest areas for winter increase in usage. Now I'm going to look at sort of what the future holds. Because of this high usage across the winter months and the variability of renewables and the way the grid is being developed, the future in the UK has been outlined in a government paper called Clean Power 2030. And some legislation has come along with this. At the moment, we don't have enough data in the UK. So there's something called mandatory half-hourly data on all meters, which is the market-wide half-hourly settlement coming in fairly soon. It's actually started. The legislation is happening now from October for the next 2 years, and it's where every meter, business meter in the country, will be required to deliver half-hourly data. And if it's not doing so within 6 days, you'll have to have that meter fixed. The follow-on to this regulation is something called the mandatory smart meter regulation, which is coming in 2027, which will require your suppliers to have this half-hourly data to give you a contract. So post 2027, if you don't have half-hourly data and your meters aren't working, you won't be able to get an electricity contract. And so what you'll end up doing is dropping off onto a deemed very expensive rate from your existing supplier, who will not be able to issue with a new contract. The whole drive behind this is to get more data, is to get the data that should be available from the grid, so they can drive flexibility. Right, what does flexibility actually mean? So flexibility is around how here, this is your actual site, how you're running during the day, and then looking at how data can inform when and where you get your energy, when you use your energy, and where you get it from. So kind of time of use, the old time of use tariffs, but brought up to date. One way of doing this is using digital twins. So this has been used very effectively across many sites. It's saying, okay, if we've got the data from our existing site, let's just model that in a sort of a virtual environment to see what would be the effect of putting solar on the roof or changing some of the equipment. This is a schematic of a school group, and also, sorry, a manufacturing group, where they've installed sensors into their energy. There's even sensors here on their doors and their windows, sensors on parts of equipment, so they can see that as these assets are turned on, turned off, the footfall into the buildings, things change. And the reason for doing this is to then see if they can take advantage of the much more granular energy usage, energy pricing that's available in the market. This looks like a very complicated graph, but effectively what it is each one of these blue dots is the energy price in a particular half-hourly period of a day over the entire year. I don't know if anybody watching has solar and batteries at home, and they're on an Octopus Agile tariff, but this is what these dots represent. These are the half-hourly pricing of the Octopus Agile tariff through the entire 12 months. So this is a domestic graph, hence some of the prices are quite high. So what you're looking at here is, this is the winter, as we were talking about, the sort of the October through to sort of March window, and some days the energy prices were capping out at £1 a kilowatt. On other days, when there was a lot of wind energy in the system, they were down at a negative figure, which effectively means anybody on this tariff, actually, we were being paid for using energy, because there's too much energy in the system. The grid needs that dumped or used up to protect the system, so they're paying people to use it. This is the power of flexibility. Where using energy flexibility across your site should allow you to live is in these green boxes. So the power of flexibility, where you're turning off, having a battery, having solar, allows you to say where and when you get your energy from. And this will keep you in the, or as I do at home, in the sub 20p bracket. Bearing in mind the domestic level, the average fixed price is probably around the sort of 26-30 pence. I'm considerably performing sort of under the market, and this is something we need to do in business. Right. Imagine this is your factory, this is your facility. This is just quite a simplistic view of how this operates. On your site, you have a number of equipment. You'll have condensers, compressors, your LEDs, refrigeration, production line. You're taking energy from the grid, as everybody else is. You may have renewables. You may have mainly sort of solar panels, and you may even have a BMS system that's controlling the majority of your assets. That's pretty much where the majority of businesses and industrial facilities across the UK are currently sitting. Let's move that forward to the 2026 to 2030. You need to reduce your costs, you need to reduce your consumption, and you need to reduce your emissions. The way to start is to get this data online. So you've seen this already. This is our Panoramic Power. This is just one example of a data platform. We bring that data internally. Now, having an energy manager looking at that is great, but they've got other things to do. So what we're looking at going forward is grid flexibility and energy flexibility delivered by an automated system. So you have all your systems on site, you have this data, and that gets fed into a machine learning model, into an automated system. Let's call it an AI system. So that's now looking at your data, and it knows what your energy is coming into the building. It knows what energy you need. It allows you to actually decide where and when that energy should be used. So, as for instance, if the pricing is high and you need to, and you have controllable loads within your site, i.e., air conditioning, refrigeration, then you should have a system that says, "Oh, lovely, the price is too high, or the carbon's too high. Let's control that load and reduce it." You may have the ability to put electric vehicle charging, and in the future, you'll be able to use your vehicles. Batteries, you'll be able to sort of draw on those batteries as well as charge those batteries. You may have an energy storage battery on site as well. So when you, in the middle of summer, if you've got your renewables are sort of producing more than you need, you can drop that into your batteries and use that. You may even get to a point where you'll be able to export energy when the grid requires it. And this is really where some businesses are already at, and I think the majority of businesses need to go to make energy a competitive advantage. Realistically, what we're looking at is taking this and using it to procure energy better. At the moment, very few people can use energy flexibly, so they don't buy it flexibly. My advice has always been over the last 20 years, if you can't use energy flexibly, do not buy it flexibly. So this is maybe a fixed tariff that many people are on. Let's say it's 23 pence per unit. Below that, in the actual market, as you saw from that the agile tariff, energy is being priced every half hour. What that looks like is this. So each one of those half-hourly dots on that blue scatter graph was represented by one of these. Quite typically, I mean, this is the first 5 days of November. Quite typically, in the early hours, there's not much consumption going on, so the energy prices on the wholesale market are very low. This is the time when people actually start getting up, waking up, putting kettles on, businesses start coming in, and this is the period when many people are getting home, turning their boilers on, cooking their meals, and also industry is still operating. So as you can see, the price curve through the day is not your 23 pence a unit. A lot of the time it's below, but sometimes it's above. So this is a risky area when it's in the 4 to 7 p.m. mark. But you've got lots of opportunity out of that. So imagine through the system we have in your building that you have renewables, you have a battery, you're able to import and export particular signals from the grid. And at this point, the grid will be saying, when the prices are high, please don't use much energy. So you can switch over to your batteries at that point, or switch down some of your air conditioning or refrigeration, which will allow sites that embrace this in the future. Excuse me, I'm not sure what's going on there, will allow you to track through this white line, if it would stay there. Apologies for that. So basically track through the lower curves and then drop out to a battery. If I just show that again. It's working now. So there you can see in the expensive periods, your controller said, let's get off grid, use the battery as much as we possibly can, turn down refrigeration, turn down air conditioning, because frankly, if this period starts at 4 o'clock in the afternoon and your staff go home at 5:30, 6 o'clock, if you turn off the air conditioning in the building, they're not effectively going to notice. And by the time they do notice, they're putting their coats on to go home. So this period, you could effectively sort of reduce consumption or run from batteries on site. So that pretty much reflects a sort of a 30% reduction in your costs compared to that 23 pence. Not many sort of areas or businesses can use this at the moment because they don't have the data and they don't have the control to do this. But this is something we're experimenting with one of the big suppliers who are very interested in moving sites to this pattern of purchasing. It also feeds into your carbon emissions. So if you are very concerned about your carbon emissions and how you can actually get down to net zero, even though you're doing as much as you can, this is a way of looking at the underlying carbon emissions in the grid. So at the moment, 2025 is predicted to have a grid emission of 103 grams of CO2 per kilowatt. So this line up here, very similar to the 23 pence a line, but 20 pence per unit line, but this is carbon. If you were buying the energy along this trajectory, you'll be able to declare carbon along a similar trajectory, insofar that each half hour of grid generation has a different carbon intensity, which delivers this sort of 103 average. So you'll be able to, and this is required under SBTI version 2, to declare your carbon on an hourly basis, if not a half hourly basis. So as you can see, same sort of pattern. And when the carbon emissions go up through the roof, where a lot of people are saying unplug, don't use, you can just switch out to your renewable resources, as well as unplugging and turning down sort of assets like refrigeration and air conditioning. So again, on price, on costs, you're looking to get a 30% reduction, but also on carbon. So on carbon emissions, you're looking at about 30% reduction, which is, I think, the two biggest levers we have between now and 2030 to actually deliver both our costs, consumption, and carbon targets. So going back to the sort of top line of sort of heat, light, and the effects of cold and darkness on our businesses over the winter, key things: get more data. Can't stress that enough. Get data from your fiscal meters. Choosing a DCDA with the right credentials to sort of carry you through into the new world. Getting controllable data on site, and also looking at sort of what you can do with your existing assets. And also on the lighting side, looking at, if you've done LEDs, but let's see what you can do to sort of in the next 12 months to out to 2030 to actually sort of make that extra change. So I hope that's been helpful. So I'll just hand back to Nadine, and I think we've got a few questions that have come in.
Thank you, Richard. That was very insightful, actually. I mean, actually, as you said, the key is data. But before we wrap up, I've got a few questions. A few questions have come in. So let me see here. Here's a question. Tell me more about market half-hourly settlement regulation and what it means to our business. So I'm going to hand you over to, I think Richard can answer this one. There we go.
Yeah, very interesting. This is a piece of regulation that's missed a lot of people. In fact, I was talking to a city council the other day who have 1,000 assets and they haven't heard of it. So it's not been widely put out there, but it is with the suppliers to sort of put this in place, which is a bit of a worry, as I'll mention. So what does market-wide half-hourly settlement mean? What it means is that every commercial meter, right the way down to if you have a meter you pay a bill on that sort of lights your stairwell, right the way up to your main production meter, needs to be producing half-hourly data. Most of them are actually set up to do it, but a lot of them haven't been switched on to deliver that level of data. There are a lot of dumb meters out there, I'm afraid, in meter portfolios that aren't available to sort of provide half-hourly data, and a lot of big meters are already doing it. And what the grid needs is the information to control the energy reserves and how the grid works with all the renewables coming in. It's absolutely critical. We're not able to do it. You can't control a grid with a lot of wind and solar assets coming in if you're working on meter readings that are out of date by 12 months. They need half-hourly data to do this. So a legislation has come in that basically says if you don't have your meters doing that, then they need to be upgraded. This has been given to the suppliers, and what's going to happen is the suppliers will sort of turn off a lot of their meters to then bring them onto a new system where it picks up the half-hourly data. The issue for all of us in business is if that doesn't work particularly well, or our meters are not transmitting data, they will send out a meter reader to pick up that data once a week, and we will be charged for that. I've been told by one meter reading organisation, the client, the bill payer, will be billed somewhere between £30 to £300 each time that happens. Now, we all know the suppliers are not great at even sending us a regular bill, a normal bill. So having them in charge of actually switching our meters out and sorting out those payments is not really I want to be kind, but I don't think the supplier should have been given the job to do that. The meter operators should have been doing that. And we as business people need to take charge of our own metering portfolios. So my piece of advice here is look at how many meters you've got. Are they smart meters? Are they AMR? Are they producing data? If not, and we can do that, we can tell from, we have access to the grid, we can see what sort of meters portfolio consists of. Get them upgraded and go to a DCA, something like Stark or one of the other data collectors. You know, we use Stark, absolutely brilliant company, to actually control your own destiny. Really, you need to be controlling your metering. You need to have that relationship. It doesn't cost any different because you're either paying to the supplier to do it or you're paying your meter operating company to do it. So my advice is have that direct relationship with where your data is, because it's your data. We can handle that. We've been doing that for many years, but it is a big piece of legislation where the 1.6 billion meter reads we have at the moment is going to go up to 62 billion meter reads. So it'll be a lot of data, but a lot of opportunity for things to fall over. So what it means for your organization is if your meters are not ready for this transition, it will cost you a lot of money and a lot of grief if you're with a supplier like BG Light or one of the other sort of very budget companies who don't really respond well to sort of problems. You'll have probably 12 months of issues and costs when it could have been done fairly simply. Any other questions?
Thank you, Richard. We do have one more because we're running out of time. So the question is, how does the data platform get installed and work? Who's going to answer that? Is that Richard? Or Richard, do you want to answer it? Or
yeah, no, I have to answer that one.
Okay.
Yes, it's there are various platforms out there and various types of sensors. The at one end of the spectrum, you've got sub-metering that has to be wired in by an electrician. You have to have a box on your wall. It probably costs about £4,000 to get a single distribution board sort of looked at and monitored. At the other end, we have clamps that are available on sort of on eBay and sort of from electrical retailers. We just clamp onto a circuit. You then leave it there for a day or so, take it away and look at the data. Neither of those really works particularly well for long-term control. The platform one of the platforms we've been using for quite a while is something supplied by Centrica. It's called Paramount Power, and the reason I like it is we showed those orange little boxes, very easy to clip onto cables. Any competent electrician, even an incompetent electrician, anybody who's qualified to operate in those panels can very easily clip those on. They've got little barcodes on which then go into the software to tell you where that clip and what it's measuring. 250 of those can transmit out to a single box, which maybe has a SIM card in, and you can have it in your pocket. So there are apps and online, and it's very simple to see what individual pieces of equipment are doing at any point of the day. And then there's quite a lot of reporting behind it. You can compare one to the other. The beauty is once you've looked at one area, unlike the fully wired in solutions, you can just unclip them and take them to some other part of your building or facility and do exactly the same. Also, compared to the data loggers you have to clip on, you have these things sitting there 24/7 delivering information to you, to your pocket. So you can see if you go and make a change to a compressor, change some set points, change some timings, you can see the return on investment of doing that. So it's a really nice solution that sort of sits in the middle of the two traditional solutions. Highly effective. None of these things are particularly cheap, but this has had probably the best return on investment that I've seen in the last few years.
Thank you. I think that's the end of our question and answer, but I'd just like to thank Richard and Gemma. It was a fantastic overview of both the current market and practical ways to reduce your energy consumption. So if you haven't got your question in, please send it through or email us at info@bcrassociates.co.uk and we will get back to you. And we will send you the recording. So yeah, so look out in your inbox. Thanks very much. And that's a wrap.